Well, gang, we made it to the last lesson of first semester, section 3.4. It'll take us 2 days to cover it, but you've made it. I mean, you have learned so much about calculus in a very weird environment of this last semester, and I'm just really so proud of how you guys have all done handling all this. We're just going to divide this up into 2 days. We're going to do day one, we're going to do exponential functions, so think like e to the x. And then day B, we'll do logs, and then that'll be it. That's the last lesson of the semester. So today we're going to focus on the derivative of equations that are in exponential form. So that means a to the u or e to the u. That means that the base is a numerical value, a number. So e is a number, just like 2 or 3 or 5 or 17. And then u is where the variable is. And remember, u is not a single variable. U represents a whole quantity of variables that could be up there. So let's review the power rule. We've learned earlier this year that the power rule is pull the power down to the front. So we get n to the, and then x, and then we subtract 1. And then if we need to, we'll do the chain rule on what's on the inside. Okay, so that is the power rule. And so if we practice that on these problems, we'll see, okay, well, y prime. Okay, so I pull the power to the front, so 0.85 would go in the front. 3x minus 1 stays on the inside, and then we subtract 1, which gives us a negative power, negative 0.15. And then we multiply this by the chain rule of the inside, which would be 3. And we'd want to clean this up so that we don't leave negatives in our exponent. So we'll have a numerator that combines the 0.085 and the 3 in multiplication, which will give me 2.55. And then the denominator would be parentheses 3x minus 1, and the power would be positive then in the denominator. The next problem is also a power rule problem. It doesn't look like it because it's not written the right way. So we would want to write this as sine parentheses 2x, and then outside of the entire parentheses is going to go pi. Now we know this is a power rule because pi is a number, just like 0.085 was a number. When the power is a number, any kind of numerical value, whether it's rational or irrational, if the power is a number, then we use the power rule. So our y prime would be the outside moved to the front. So pi would move to the front. And then we would decrease by 1. So we just write pi minus 1. It's just a number, just like anything else. And then the chain rule. And we remember that the chain rule of sine is cosine, but we have to leave the 2x by itself. And then at the very end, because there's still parentheses, then we'll do the derivative of 2. So if we're going to write this in a better way, you would combine the 2 and the pi out in the front together as coefficients. So that would be 2 pi. And then probably put your sine of 2x next to the pi minus 1 power, and then cosine of 2x without a power at the end. So that's probably how you write your final answer. So when the power is not a number, we need the exponential rule. Okay, that's the big difference. Is the power a number or not? If the power is a number, you use the power rule. If the power is a variable, you need the exponential rule. So if the power has an x in it, you need the exponential rule. And here's how the exponential rule goes. If a to the u has a power in the exponent, then the derivative is this. It's itself, a to the u, times the chain rule of u, which is u prime, times the natural log of a. So that's a new piece. We've never had a natural log as part of our derivative before. So the rule is itself times u prime, and you could either write u prime or you could write du over dx. Either way, remember one is Newton's method and one is Leibniz's method, and then times the natural log of a. So let's try that with e to the u. Okay, so what would that be? All right, well, the derivative would be itself, e to the u, times the chain rule, so du dx or u prime, and then times the natural log, this time of the letter e instead of the letter a. But if you remember, the natural log of e, sometimes called ln e, is 1. So that simplifies to e to the u times the chain rule, du dx. So sometimes this is confusing with the power rule. The power rule is for numbers in the power. The exponential rule is for x's in the power. So let's practice. The power is x squared. So the power has an x in it, which means I need the exponential rule. So dy dx, the derivative, starts with itself, 3 to the x squared, times the derivative of u, and remember this is the u portion, and the derivative of that is 2x. I don't need parentheses, I guess. And then it comes the natural log of the number. All right, that is the derivative of this problem. It's just 3 pieces. The final order would be written like this. The 2 comes first, then the x, then the natural log 3, and then after that would be the 3 to the x squared would be usually listed last. And lots of times you'll see the natural log of 3 put in parentheses. Okay, it's kind of flexible whether you use a parentheses or not. All right, here's another one. Okay, so you look for the variable. Okay, I see the variable here. It's part of the power. It's part of the exponent, and so I need the exponential rule. So y prime says, start with itself, 5 to the cotangent of 3x. Then multiply by the derivative of u. And the derivative of u, well, u is this whole portion up here. So the derivative of that starts with the derivative of cotangent. Okay, remember what the derivative of cotangent is? Cotangent and cosecant. Excuse me, I even got it wrong. The derivative of cotangent is cosecant squared. And now I leave the inside alone. Then the derivative of that parentheses, which is 3. And then the natural log of the number 5. Okay, so they're all their pieces. You start with the problem itself, and then multiplied by the derivative, du dx, and then the natural log part. So let's clean that up. So in the very front would go 3, and then probably ln 5. And then next would come the square, so cosecant squared of 3x. And then at the very end would come the 5 to the cotangent of 3x. That's the typical order. Okay, find the derivative if y equals e to the x cubed. All right, well, where's the x? It's in the exponent. What does that mean? I need the exponential rule. So dy dx says exponential rule, use itself, then times the derivative of the exponent, so 3x squared, and then times the natural log of e, which is going to be 1. So we'll put this in the right order. We'll put the 3 in the front, and then the x squared, and then e to the x cubed. Okay, let's find a tangent line. So remember, for a tangent line, we need a point, and we'll need a slope, and then we'll need to write the tangent line. All right, the point is going to start with pi, because that's what we were given, and then we need to find the y value. So to find the y value, we're going to plug pi into y. So y equals e to the sine of 2 pi. Do you remember what the sine of 2 pi is? The sine of 2 pi is 0. Do you remember what e to the 0 is? E to the 0 is 1. And so my point is pi comma 1. My slope, I have to figure out dy dx. Because x is in the exponent, right here, I need the exponential rule. The exponential rule says start with itself, and then do the derivative of the exponent, so sine turns to cosine, leave the inside alone, and then the inside. And then comes the logarithm, and the natural log is of e, which of course will turn to 1. So in the right order, we'll have 2 in the front, and then we'll have the cosine of 2x, and then we'll have e to the sine of 2x. And now we want to find this is the derivative. Now we want to find the actual value of the slope by plugging pi into my x positions. So that'll give me 2 times the cosine of 2 pi times e to the sine of 2 pi. Okay, do you remember what the cosine of 2 pi is? Hopefully from your unit circle you remember that that is 1. And the sine of 2 pi from our unit circle is 0. So we end up with 2 times 1 times e to the 0. But e to the 0 is also 1. So we end up with 2. So my tangent line then in my form is y minus the y value of 1, the slope of 2, and x minus pi. All right, here's another way we can ask a question about derivatives. Find the points when y equals 2 to the 3x plus 1 is parallel to negative 4x plus 5. Now this doesn't look like maybe it's a calculus question, but let's see how we would actually use calculus for it. Remember, the word is parallel means same slope. Okay, that's what it means to be parallel. And the word slope is the same as derivative. So they have the same derivative. So we need to find the two different derivatives. So let's start with y equals 2 to the 3x plus 1. What would its derivative be, y prime? Well, because x is in the exponent, we use itself times the derivative of 3 times the natural log of 2. And so if we put this in the right order, we'll have 3 parentheses natural log 2, and then 2 to the 3x plus 1. Now the other derivative, y equals negative 4x plus 5, that derivative is just negative 4. That's a pretty easy one. Now we want to find out where these two derivatives are the same. And so we have to set them equal. So we set 3 times ln 2 times 2 to the 3x plus 1 equal to negative 4. And this is really too difficult for us to solve by hand. So, I mean, I could solve it by hand, but I think it'd be easier if I solved it by graph. So when you want to solve something by graph, you put one of the equations into y1 on your calculator and the other one into y2, and you look for where they cross each other. And before we graph it, I really apologize. I'm realizing that there's a typo in my notes, so I'm so sorry. This is not supposed to be a negative. So cross that out in your notes, which means this shouldn't be a negative, which means that shouldn't be a negative. Okay, now we're ready to graph it. So I'm going to put this into y1, and I'm going to put it into y2. So here's my sketch of what I see when I graph this just with a regular window. My y1 comes up and then goes up like an exponential, and my y2 comes across and intersects, like kind of looking like that. And so we want to know, where do these two things intersect as the answer? Now the naked eye, it looks like, oh, they're going to intersect at 0, 4. But make sure you don't just believe your naked eye. Make sure you do second trace and you do the calculate feature on your calculator, because this turns out to be negative 0.187. Okay, so don't just say it's 0 because it looks like it's 0. Make sure you actually calculate it. And so that's the value where these two equations would be parallel to each other. Okay, so let's just quick review. Find the derivative of 4 to the third. Okay? The power is a number. And because the power is a number, we use the power rule. The power rule says move it down to the front, subtract 1, and do the chain rule. And so the answer to this would be 3, 4 to the, subtract 1, I get squared, times the chain rule of 4, which is 0. So 3 times 4 squared times 0, which turns out to be 0. All right, the next question. The power is also a 3, so I do the power rule again. Pull the power to the front, subtract 1, and remember the chain rule. So for this one, y prime would be 3x to the second times the chain rule of 1, which turns out to be 3x squared. But in the third one, the power is an x, which means I need the exponential rule, which is different. The exponential rule says start with itself, then multiply by the chain rule, which is the derivative of x, which is 1. Then multiply by the natural log, which is 4. Okay, so it's important for you when you're looking at these questions to identify what kind of power do I have. Is it a number? Then I use a power rule. Does it have an x in it? Then I need the exponential rule. All right, if you could go to the end of your notes, just like on some blank space, I have one additional example I decided to add, but I didn't reprint your notes out. So this is one final example of what I want to do with you. And we want to find the derivative of y equals e to the 2x x squared. The reason I wanted to review this is because a couple of the problems in your homework refer you to the product rule, and we haven't really talked about the product rule since we got back from Thanksgiving break. So I want to talk about that with you, how there is the implied multiplication here between these two things. Okay, it's not always written there, but this is the implied multiplication. So you've got an a term and a b term. And so when you take the derivative, you do need the product rule. You can't just forget all your rules from before. So dy dx, you would have the 4 parts of the product rule. So you'd have your b, and then your a prime, and then your a, and then your b prime. So the b part would be x squared, and the a prime part would now require an exponential. So you'd have e to the 2x times the chain rule of 2 times the natural log of e. And then you'd have your a part, which is just the e to the 2x part, and then your b prime, which is 2x. So let's clean all this up, remembering that the natural log of e is 1. So I'm going to lead this term off with 2, and then x squared, and then e to the 2x would be at the end, and then plus, and then I'm going to put 2x in the front and e to the 2x. Now the best way to write your answer for a product rule question is to look for what they have in common and write it as a GCF. So hopefully you notice that they both have an e to the 2x, they both have a 2, and they both even have some x terms here. Not exactly a match, but close. So we would write that as a GCF. So the GCF on the outside would be the common number 2, the common x, and an e to the 2x. And then in parentheses, we would put what was left over. So an x and then a plus, and you have to have something after the plus sign, so that would be a 1 because you took everything out. You took out the 2, you took out the x, you took out the e to the 2x. So the best way to write that answer is in factored form, where you've pulled out what the terms have in common. All right, so that leads us up to logarithms as our last day. So when we gather together on Wednesday morning, we will tackle the derivative of a logarithm expression. All right, so it's been my privilege to work with you guys so far this semester, and I look forward to wrapping up with you on Wednesday.